Motion in our daily life can take many forms. The Diwali rocket executes translatory motion. Some more examples of translatory motion are the motion of a parachutist, a bullet fired into the air, and a football kicked into the air. The other type of motion we come across very frequently is rotatory motion. The rotating motion of the blades of a fan is an example of this type of motion. Other examples are the rotating motion of the blades of a mixer grinder and the rotation of the blades of a turbine. In these examples, the motion repeats itself after a certain fixed interval of time. Hence, this type of motion is called periodic motion. Periodic motion is exhibited by all the planets revolving around the Sun, since each planet has a fixed time interval for each revolution around the Sun. Periodic motion is also exhibited in other cases, such as the to and fro motion of a sewing machine needle and the movement of the piston of an engine. The to and fro motion of a body is called oscillatory motion. Let us consider a string fixed tightly between two walls. When the string is plucked and released, it executes to and fro motion. All oscillatory motions repeat themselves after regular intervals of time and hence are periodic motions. However, every periodic motion need not be an oscillatory motion. In the oscillatory motion of a body, there is a force that always directs the body towards the position, which is the position of zero displacement. This position is referred to the mean or rest position. This force is the restoring force. For example, in the spring shown here, which is fixed to a rigid support and the mass attached to the spring oscillates. The spring oscillates about the mean position. The motion of the bob of a simple pendulum is another example of oscillatory motion. In the simplest form of oscillatory motion, the restoring force on the body is proportional to its magnitude of displacement, but is opposite in direction to the displacement from the mean position. This type of motion is called simple harmonic motion. Simple harmonic motion is the to and fro motion of a body, where the force is always directed towards the mean position and is proportional to the displacement but in the opposite direction. Thus, the simple pendulum and the spring with vertical oscillations are executing simple harmonic oscillations. The oscillation of a boy on a swing is an example of simple harmonic motion. In practice, oscillating bodies come to rest at their rest position due to external forces which oppose the motion, called damping forces. The energy of the oscillating bodies dissipates due to the damping forces, and hence the oscillating bodies lose energy in the course of time. Hence, the boy swinging on the swing gradually comes to rest. To maintain the oscillations, the swing must be pushed by somebody such that the swing always reaches the same extreme positions. The person pushing the swing applies an external periodic force, which allows the swing to continue its oscillations in spite of the damping forces. Thus, understanding the concept of oscillatory motion helps to understand various physical phenomena.